Alright, so welcome to part 2 of solving these mechanics problems. I'm going to do number 3 now on the first sheet. So in this problem I say that there's a car stuck in the snow. Alright, and the car, no, that's not the car stuck in the snow problem, sorry. Let me restart. You're trying to push a 400 kilogram object. That's pretty heavy. Alright? The maximum force that you're able to give is 3,000 newtons. Alright? There's a normal force acting on the object. There's a force of gravity acting on the object. And there's also a force of friction acting on the object. We'll call it static friction because I'm trying to get this object to move. And therefore that means it's not moving yet. Now I want to know, how smooth does the surface have to be for me to be able to push it with 3,000 newtons? Alright? In order to find that, we need to find what the force of friction is first. Alright? So let's go do our x and y tables. So I have the force of gravity, the force of the normal, the force applied, and the force of friction, and then the total force. Alright, the force of gravity has no x component, force of normal has no x component, force applied has no y component, force of friction has no y component, it's not moving in the up and down direction, and that's it for now. I saw Zoe doing this, so I'm going to show you guys what she did, and maybe it'll help you out. Before she did any calculations here, she decided to already write down the signs of all her forces. So she knows that the normal force is positive, the force of gravity is negative, the force of applied is positive, and the force of friction is negative. This relieves her from any duties in terms of remembering to put signs or forgetting to put signs. And this is an excellent trick, and I encourage you all to do it. Alright, so now that that's done out of the way, let's figure out what the force of gravity is. Force of gravity is 400 kilograms times 9.8 meters per second. And that's equal to 3,920 newtons, or negative 3,920 newtons. That means this is positive 3,920 newtons. Alright. Now, the force applied, we said is the maximum force applied is 3,000 newtons. Alright? And we know that at 0.0001 newton, we start to move an object. Alright? If the overall force is 0.0001 newton, we start to move the object. So what do we need to at least get just over 0 newtons, which is just exactly what I need to get the object moving? And in order for me to do that, I need to have a force of friction of negative 3,000 newtons. And if I have negative 3,000 newtons, that's the most friction I'm able to work against, right? So if the force of friction is 3,001 newtons, I wouldn't be strong enough to move it. So I need to have a force of friction that's exactly 3,000 newtons or less. And if it's 3,000 newtons or less, what would be the coefficient of friction in that case? So it would be, if I needed to have at least 3,000 newtons, and in here, and because I'm calculating the coefficient of friction, I don't need my signs anymore. I know that 3,000 newtons is equal to the coefficient of friction, and the coefficient of static friction, times the normal force, which is 3,920 newtons. And therefore, the coefficient of static friction is equal to 0.76. And there's my answer for number 3. Alright? Now it's telling you, in the above problem, the coefficient of static friction is actually 0.25. So we said that this was the maximum coefficient that I could do. If it was any rougher than this, if the coefficient of friction was any higher than this number, then I couldn't push it anymore. Alright, so it's telling me now that 0.25 is actually what it was. So I should have no problems moving this. Now it's asking me, what is it going to be my acceleration if that were the case? So I have my 400 kilogram object, and now we're into number 4. I have a normal force. I have a force of gravity. of the applied force, 3000 G, sorry, 2000 N, 2000 N, and I have a force of friction that now I know. So let's do the X and Y. I have the force of gravity, the force of the normal, the force of friction, and the force applied, and my total force. Alright? Let me just fill in my stuff. Negative, positive, positive. Alright, so we're good to go. Force of gravity is the same as above, 3,920 newtons. The normal force is therefore 3,920 newtons in the opposite direction. The force of friction is 0.25 times 3,920 newtons. And that's equal to 980 newtons in the minus direction, and my force applied is 3,000 newtons in the positive direction. So my resulting force is 2,020 newtons. And what's my acceleration, you ask? Well, that's easy. We just have to do mass times acceleration to figure that out. So 2,020 newtons is equal to the mass, which is 400 kilograms, times an acceleration. And the acceleration is therefore 5.05 meters per second squared. That's my answer for that. All right? Okay, I hope that made sense. Now I'm going to move on to the second mechanics problem sheet. So that's again going to be in a new video. Thanks.